as a voltmeter. It is possible, huh? Of course, of no use, but it's possible. We can manage like this also. Connecting R1 across this. So even this also voltmeter is, because what we have is voltmeter resistor connected in series. Okay, I can bring like this also, that one. Even this also will work as voltmeter. And even for ammeter, there's a voltmeter. You can have a situation of like this. Even for ammeter, this will be R1, this will be R2. That's the same condition. There's milliampere I'm showing. So there's a maximum current what it can measure here. Fine. So even this can be ammeter. There's no rule that only R1, only resistance should be in parallel. Even you may get a resistor in series also like this, even in case of ammeter. So what they do is they'll give ratio of R1 by R2, they'll give range, they'll ask you to work out. So here what's be the, how the basic formulas will be. Vm should be equal to Ig into R1 G by R1 plus there's a formula. So what will be given for you? They'll give Vm, high G and capital G. There's a range they'll give. They'll give R1 by R2 some ratio. And this one more equation you have. So two equations to unknown you can solve. There's a modified voltmeters also used in applications of this kind. Books not discussed, they're possible. Similarly, what is the expression for Imax? So here we'll assume Ig will flow Imax minus Ig. So this Imax should be equal to sorry, they're parallel, no? So we'll apply the Imax minus Ig into R1 is equal to Ig into G plus R2. Here also I'll give the ratio of R1 by R2. From that, like and I'll give Imax, then I'll get the other thing. So these are the ideas. I'm just sharing it. It can be like this also to trouble you, because usually ammeter means we never think that okay there should not be any resistor. Voltmeter means there should not be any R1 parallel to this, but it can happen. Fine.